Assalamualaikum and hello everyone. So today we are from group 9. We are going to present about the advantages and disadvantages of cast iron engine. Next slide. Okay, so this is the list of our group members. The first one is Haris Zikri, followed by Tihani Patricia, Nur Amira, and the last one, which is me, Azida. Next. Okay, so we'll start off with the introduction for cast iron. So, what is cast iron? Cast iron is a group of iron carbon alloys with a carbon content about 2 to 4%. It is very fluidy in molten state. The next one, when it solidifies, the size does not shrink much. And the fourth one is the carbon content makes it very hard but also brittle. So cast iron is typically used in manhole covers, guttering, and drain pipes, and also cylinder blocks in engine, which we will discuss about later. Next slide. So we'll go to the type of cast iron. There are 4 types of cast iron. The first one is the grey cast iron. So the grey cast iron is the most common type of iron cast. Grey cast iron features a graphite microstructure consisting of many small fractures. It is called grey cast iron because of the presence of these small fractures creates the appearance of a grey color. So you guys can see the picture for its microstructure. Then when grey cast iron is produced, the fractures open up to reveal the grey colored graphite underneath the surface. So grey cast iron also offers similar compressive strength as steel. So the next type of cast iron is the white cast iron. So the white cast iron receives its namesake from its off-white color, which is the result of iron compounds known as cementite. So like grey cast iron, white cast iron also features many small fractures. You guys can also see the picture in the slide. So the difference is that white cast iron features cementite below its surface, whereas the grey cast iron features graphite below its surface. So the graphite creates the appearance of a grey color, while the cementite creates the appearance of a white color. So the difference is the color, and also the white cast iron is hard and also brittle. Last but not least, white cast iron offers excellent resistance against abrasions. Abrasion is scrap or scratch on the surface. So I'll pass this to the next presenter.
Okay, I'm going to present the third type of cast iron. So the third type of cast iron is a ductile cast iron. It is a type of soft ductile iron alloy with a high carbon content. Okay, so you can see in the picture here is a ductile cast iron in the microscope. So in ductile cast iron, graphite is in the form of nodules. So whereas a sharp graphite flex creates stress concentration points within the metal matrix. It also contains a rounded nodules that inhibit the creation of cracks. So that is why it providing the enhanced ductility that gives the alloys its name, which is a ductile cast iron. So what is nodules? So to form a nodule, we need nodularizing elements. So nodularizing elements can be achieved by nodule formation, such as we could see that commonly the nodularizing elements is magnesium balls at 1100 Celsius. Uh, so in a way, when we use a magnesium at balls at 1100 Celsius, we will get a nodulizing elements. Okay, for the fourth one, which is a malleable cast iron. So malleable cast iron is basically from white cast iron that have been converted. So how does this process happen? Basically, the white cast iron is converted to marble cast iron by a two-stage of heat treatment process. So after the heat treatment process, they are in a condition of having most of its carbon content in the form of irregularly shaped granules of graphite, and that is why it called tempered carbon. You can see in the picture here, the structure of marble cast iron consists of ferrite, pearlite, and tempered carbon. So next slide, I'm going to talk about application of cast iron. So the first one is curtain. Basically, we will use to saw this in the side of the roof, on the at the house. So it is mainly function to prevent water ingress into the fabric of the building by channeling the rainwater away from the exterior of the walls and their foundations. So it could prevent from the rainwater to be filled up on the roof. And the next one is cylinder blocks in car engine. Basically mainly used for the cars, for the car engine. It is to maintaining the engine stability and lubrication while withstanding a variety of temperature and loads. Basically, it could become a resistant for the condition of the car engines. And the third one is the manhole covers. So we will use to saw this on the road and the streets, and it is used to an access point for an underground vault or pipe. So I will pass to the next presenter.
Okay, next I will explain to you about the advantages of cast iron. There is four advantages of cast iron, and the first one is cast iron is typically cheaper and easier to rebuild. A cast iron engine block is often cheaper because of the lower material cost, energy, and labor required to produce a final product. Besides, cast iron has been used in industry for many years and is fairly easy to produce. Iron engine block is less likely to be distorted during the rebuilding process, which make it easy to rebuild. The second advantage is it has much better wear resistance. Cast iron typically has better resistance to mechanical wear than steel, especially in friction wearing situations. Cast iron has good resistance to corrosion due to the microstructure component compound such as graphite and phosphate eutectic, and the tough surface can form as the casting is cooled. The high graphite content in cast iron creates a graphitic dry lubricant allows solid surfaces to slide against each other without deteriorating surface quality. Okay, next slide. The third advantage of cast iron is great at absorbing noise and absorbing vibration. The graphite structure in cast iron, especially the flake formation in grey cast iron, is good for absorbing vibration. This makes cast iron ideal for engine block, cylinder housing, and machine beds, and other applications where sturdiness and precision are important. Reducing vibration can minimize stress and prevent wear on moving parts. This makes cast iron ideal for engine blocks. And the last advantages is more stronger. Cast iron has higher strength at reduced cost. Cast iron engine block is more strong and stiff because it typically can take more boost power than aluminium engine block. The strength of cast iron make it a workable material. They have high strength, high heat resistance, and toughness. They are used in a wide range of industry such as engineering, agriculture, and automotive. And lastly, it has a low melting point and greater fluidity. Okay, next one.
Okay, now I'm gonna explain about the disadvantages of cast iron engine. There are four disadvantages in this slide. Okay, the first disadvantages is the cast iron is more heavier. The cast iron is weak, brittle, and non-ductile. So, the cross-section of the components of cast iron are made thick, strong, and sturdy to withstand the loads required to be sustained. So, due to the heavier weight of cast iron block engine, it leads to a slower acceleration of the vehicles and takes more fuel to move it around. The second disadvantage is the cast iron engine is poor heat conductor. Okay, for example, when we compare the cast iron engine with aluminum engine, the cast iron engine is typically reach operating engine temperatures more slower compared to aluminum block engine. So, this means that iron block engines are less capable of transferring more of their heat away onto their coolant, which can lead it to run more hotter than aluminum engine block. The third disadvantage is the cast iron engine is difficult to repair the cracks. Okay, actually the iron engine block crack can be repaired, but it is still a pretty difficult as it requires a great skill, a good furnace welder, and etc. to repair it. It is it is also takes a long time and a lot of process that involve just to fix it. However, the often rate in achieving the success of repairing the cracks is lower than aluminium block engine. Okay, the last disadvantages is the cast iron engine is brittle, hard, and non-malleable. Why is cast iron is so brittle? This is because the internal carbon particles create internal stress points conducive to fracture. So that is why the cast iron is harder, more brittle, and less malleable than wrought iron. It cannot be bent, stretched, or hammered into shape. Since its weak tensile strength means that it will fracture before it bends or distorts. Next, so that's all from us. Thank you for hearing. Bye.